Lesson 6.2 is about solving systems of slope-intercept equations by using substitution. So our objective here is, given a system of equations in slope-intercept form, solve using algebraic substitution. And we're going to always check a solution to a system of equations. So the graphing method to solve a system of equations is a guess and check method. To find an exact solution, we are going to use substitution. So if a point is a solution to a system of linear equations, three things will happen. The point is where the lines intersect, the point lies on both lines, and the point must make both equations true. Now there's going to be 5 steps to solve a system of equations in slope-intercept form. First, we have to verify that both equations are in the form y equals mx plus b. Number 2, we let the right-hand sides of the equations equal each other and solve for x. 3, solve for the y-coordinate using one of the equations. 4, write your solution as an ordered pair, which is x comma y surrounded by parentheses. And 5 is verify your result, which is your check step. So in example 1, we have to make sure that, number 1, verify that both equations are in the form y equals mx plus b. Well, I have y equals x plus 1 and y equals negative 2x plus 4. They are indeed in slope-intercept form. Now, what we can say here is I have y equals x plus 1 and y equals negative 2x plus 4. We can say that y equals y. So if I say y equals x plus 1, oops, sorry about that. And on the second equation, I have y equals negative 2x plus 4. And I say y equals y. Then couldn't I just solve and shove? So I've solved them for y. Now I just need to shove this in here. So I have x plus 1. That'll go here. And I have negative 2x plus 4. And that goes in the place of that y. That's substitution. So now I say x plus 1 equals negative 2x plus 4. And this is a Philippe situation. So I have to solve for x now. So I will add 2x to both sides. Remember, this is 1x plus 1. So I have 1x plus 2x, that's 3x plus 1 equals negative 2x plus 2x, that's 0, plus 4. Now I need to remove the plus 1 by subtracting 1 from both sides. That leaves me with 3x plus 0 equals 3. So 3x equals 3. Dividing both sides by 3, I get x equals 1. So I let the right-hand sides of the equations equal each other and I solve for x. That was step number 2. Step number 3 says I solve for the y-coordinate using one of the equations. Now, I'll get the same answer for y no matter which equation I pick. I'm going to choose y equals x plus 1. Now I substitute 1 in for my x, and I get y equals 1 plus 1, y equals 2. Again, my coordinate, I need to write my answer number 4 using an ordered pair. So I have my x-coordinate, which is 1, and my y-coordinate, which is 2. I didn't number this one. This number solving for y was step 3. Now in final step 5, we need to verify our result. So our solution was 1, 2. We need to substitute that back into both equations. So I have y equals x plus 1 and y equals negative 2x plus 4. I have 2 equals 1 plus 1, 2 equals 2, check. This one is 2 equals negative 2 times 1 plus 4. 2 equals negative 2 times 1 is negative 2. Adding 4, that gets me 2. 2 equals 2, check. Sorry, you hear my cats in the background playing with their toys by the door there. Alright, that completes step number 5. Alright, let's do example 2. Number 1 says verify that both equations are in the form y equals mx plus b. Well, it appears y equals x minus 3, y equals 2x minus 8. Step 1 is complete. Step 2 says let the right-hand sides of the equations equal each other. I'm going to say x minus 3 equals 2x minus 8. Again, we have our Philippe situation. So what I'll do is I'll subtract x from both sides. So that is 0 minus 3 equals 2x minus 1x is 1x minus 8. Now I add 8 to both sides. So now negative 3 plus 8, that's 5, equals 1x. Now I divide both sides by 1, x equals 5. So up here I'll go ahead and I know that it's going to be a coordinate. 5 is my x value, comma, we don't know, we got to solve for it. We need an x and a y. Step 3 says solve for the y coordinate using one of the equations. Well, I can use y equals x minus 3, or I can use y equals 2x minus 8. It doesn't matter. I'll choose y equals 2x minus 8. So I substitute in my 5, y equals 2 times 5 minus 8. 2 times 5 is 10, 10 minus 8 is 2, y equals 2. Sorry about that. We solve for the y. Now I take my 2 and drop it up here in my coordinate. My coordinate is 5, 2. Write your solution as an ordered pair. We did that. Verify your results. So I say y equals x minus 3 and y equals 2x minus 8. So I say 2 equals 5 minus 3. 2 equals 5 minus 3 is 2. Then I have 2 equals 2 times 5 minus 8. 2 equals 2 times 5 is 10, 10 minus 8 is 2. Check. We're good. Example 3. I need to verify that they're both in the equation y equals mx plus b. That's done for us. 2, we let the right-hand sides of the equations equal each other. X minus 1 equals negative 2x plus 5. My kids are about to walk in from going to the allergy shots, so it could get a little noisy here in a second. I will add 2x to both sides. X plus 2x, that's 3x minus 1 equals 0 plus 5. Now I add 1 to both sides. I have 3x minus 0 equals 5 plus 1 is 6. Then I divided both sides by 3. X equals 2. Step 3 says solve for the y-coordinate using one of the equations. I'll use y equals x minus 1. Y equals my x is 2 minus 1. Y equals 1. Step 4 says to write your solution as an ordered pair. So up here, my x value is 2, my y value is 1. And now for step 5, we need to verify our solution. So y equals x minus 1, y equals negative 2x plus 5. My y value is 1, equals 2 minus 1. 2 minus 1 is 1, so 1 equals 1. Check. My y value is 1 again, equals negative 2 times 2 plus 5. 1 equals negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. Check. We are good.